Hello everyone, welcome to my channel Enthusiasm. Today we're going to solve this challenging Diophantine equation. 3 to the power of x is equal to y squared plus 320, where x and y are integers. First of all, an important skill in number theory is to consider the unit digits. Let's check out the left-hand side. For the first 4 powers of 3, the last digits are 3, 9, 7, and 1. As long as the unit digit is 1, multiplying another 3 will go back to the beginning. Therefore, there's a pattern of the last digits for every 4 terms. Let's move on to the right-hand side. Consider the unit digits of y. It can be from 0 to 9. Then, the unit digits of y squared in all cases are shown in the table. They can only take the values of 0, 1, 4, 5, 6, and 9. Actually, they're also the unit digits of y squared plus 320. Can you see the reason? Because the 0 has no effect on the last digit. Now, we can check out when the left-hand side and right-hand side have the common unit digit. It can only be 1 or 9. More importantly, it happens when we have 3 squared, 3 to the power 4, and adding multiples of 4 to the index. In other words, the index of 3 must be an even number. This is the key to solve the problem. Now, we can let x is equal to 2n, where n is a positive integer. Then the equation is changed to 3 to the power of 2n is equal to y squared plus 320. So what's next? Let's write down the first term in another way. 3 to the power of 2n is equal to 3 to the power of n whole square. We put y squared to the left. Can you see something special? Right, the left-hand side is the difference of 2 squares. We can factorize it. Therefore, it becomes bracket 3 to the power n plus y times bracket 3 to the power n minus y is equal to 320. Because n and y are integers, so it is also the case for the two terms in the brackets. That means we'll have to express 320 as a product of two integers. The following are all 7 possibilities for bracket 3 to the power n plus y times bracket 3 to the power n minus y. If we reverse the order of the two factors, there are another 7 combinations. However, if we solve for the n first, then it is not necessary to reverse the order. Why? Let's look at the following 2 combinations. The only difference is the order of factors 1 and 320. If we add up the 2 equations in each system, then the y terms are cancelled out. We get the same result. 2 times 3 to the power of n is equal to 321. So we only have to look at the first 7 combinations. You may wonder, what about the values of y? Don't worry, we will take care of them in a minute. Now, we have these 7 systems of equations in n and y. Just like what we mentioned, add up the 2 equations for each system. Then we have 2 times 3 to the power n is equal to these values. Actually, some of them are impossible. Can you see the reason? Because the left-hand side is an even number, therefore 321 and 69 are rejected. For the remaining 5 values, divide them by 2, then we have 3 to the power of n is equal to 81, 42, 24, 21, and 18. Out of these 5 values, only 81 is a power of 3. Therefore, n is equal to 4. Now, we are ready to solve for x and y. X is equal to 2n, which is equal to 8. Putting the value of x back into the equation, then y squared is equal to 6,241. Taking the 2 square roots, we'll have y is equal to plus or minus 79. They are the 2 solutions for interchanging the order in these 2 systems. So the final answers are xy is equal to 879 or 8 negative 79. Not as hard as you might think, isn't it? If you want to know more interesting problems about number theory, please check out the links of the videos and placed on the screen and the descriptions below. See you in next video.